Hello and welcome back to the channel. In this video, we'll be discussing Go's pointers. If you recall in a previous video where we talked about slices, you might remember when I said when we declare a slice, its default value is nil. Whereas when we compare it to arrays, when we just declare an array, it has a default value with all of the whatever data type it holds set to their 0 values up to the length of that array. So let's demonstrate that one more time as it's a good prerequisite into learning pointers in Go. So I will have a var called a, which stands for the array that we're about to make, and it's just going to be 10 integers. Then I'm going to have a var s to stand for a slice, and that's just represented with the empty brackets here, and it's going to hold ints. So we're getting an error because we haven't done anything with a or s or used the format package. So let's do a print line of a, and then let's also print s. So when we go to run this, do a go run, we get that we have some full array of zeros, and then we get another one where it's just empty. So now let's check if I do an a equals nil, which it cannot be because a is a value type, so we can't even do an equals here. But what we can do is check and see if s is nil. So when we go run this again, we get the full array printed out to us, but then we see that the slice that we declared and never initialized is nil. So you may have heard of pointers in some course, or you may have heard them in maybe intermediary programming videos. You might not have completely understood them. Pointers are commonly feared and misunderstood, but if you give them intentional thought, you can quickly master and understand the whole entire point of pointers. In reality, everything is a pointer in a computer program. But in Go, you may worry about memory management if you're coming from C. But in Go, just like Java and other memory managed languages, Go has plenty of garbage collection and other helpful tools and guardrails that manage pointer complexity. So you can really focus on what matters most when utilizing pointers in your program. Let's start with this visual demonstration of what pointers look like in memory for a program. If we start with an integer in Go, the standard Go int is 32 bits long. Now you may have heard that computer programs are made up of nothing but ones and zeros, and that's true. And each of those ones and zeros, they are called an individual bit. If we group those bits into groups of 8, they become a byte if you're running on 64-bit architecture, which we're just going to assume for the rest of this video. So if we break up 32 bits and divide it by 8, we get 4. So those groups of 8 are called bytes. And so if we have a 32-bit integer, it is therefore 4 bytes long. If we were to have a variable called x of type int and we set it equal to 3, this is not how it actually looks in memory or anything, and I'm also using incorrect numbers here. I'm not using binary representation up here, but if we have it set to 3, what it would look like is that all the bits ahead of it are set to zeros, and then we have a 3 here, and we can see that it is 4 bytes long. But we have to have some sort of mapping. We have to know where can we find this variable in memory. So therefore we have to have some sort of address or location. So we'll go ahead and say that x is stored starting at address location 1, and since we know that it is 4 bytes long, we know that at address location 1, 2, 3, and 4 is where x is located. Now, not every single variable that we have in Go is 32 bits long. We can have something like a bool, where we don't need to have 32 bits of data to hold a bool. We just need a single bit. So if we go look in memory, if we have y set to true, all we have to go and look is that address location 5 is where that bool is located, and then we can see that its value is set to 1, meaning true. Now let's demonstrate what we had in the spreadsheet over here in code. So if you remember what we had x is equal to 5 and y is equal to true. Now how can we play around with the addresses or at least view them on our machine? Well, there's two special kinds of syntax that we'll have when working with pointers. If you want to get a pointer of a value back, so such as x or y, you'll use the ampersand. If I wanted to print out the address of x, then you use ampersand and then x. Similarly, if we want to grab the address or the pointer of y, then we just do ampersand y. So now let's run this program, and we see that when x got printed, it was at this location in my machine's memory, and then when y printed, it's at this location. Now, if you're unfamiliar with how locations are typically printed on a screen, they're printed in what's called hex values. So if we convert these over to binary or a decimal, you'll see that these values are actually right next to each other in memory. What's interesting, what you can do with pointers is that you can directly access the underlying data. So if you remember in a previous video where we talked about how functions are passed by value, sort of, in Go. So when you pass x, if we were to pass x into a function, we can't modify x. So let's go ahead and demonstrate that real quick. I have a func called change x, and it takes in a value, or we'll call it change num, and we'll say num is some sort of int, and we'll reassign num to be equal to 10. That's all we want to do. So we can go ahead and call change num right here, and then we'll go ahead and print out x to see if it changed. I print out x here, we do another run of this, and we'll see that x never changed because a copy of x was passed into the function, the copy was modified, and then the function returned, but x truly never changed. So what if you wanted to be able to change the value of x? Well, that's where we start using our pointer syntax, because remember, pointers point to the location of where the data is, and so if we know where the data is, then we can directly modify it. So instead of taking in an integer value for the change num function, put a star right before it. This reads that num will be a pointer to an int. So rightfully so, we should maybe update this parameter value name to be num pointer. Here, now we just have to do the other side of the pointer syntax, where we pass in the address of x, or the pointer to x. We still have one more thing that we need to fix here, and that is if we were passed in num pointer right here, it's a pointer, and pointers are not ints. They're not bools, they're not anything else. They are pointers. They have their own special values and ways that you can work with them. So we cannot assign them a decimal value. So how can you access the data that is underlying the pointer? Well, you can dereference it. And to dereference, you use the star or asterisk. So this reads, I'm going to access the data that num pointer points to, and we're going to change the value out from under it and set it equal to 10. So let's rerun this program. We do a go run. We'll see that x got changed to 10. From this point forward, that's really all you need to know about pointers. You can dereference them with the star syntax, say that it's going to be a pointer to some sort of data type, again with the star, and then use the ampersand to grab the pointer to that particular value. You can create pointers to pointers, so I can have another star right here, and then we would just need to make a pointer to x and then pass it along, but there's really no point in having pointers to pointers, especially at beginning levels of programming. Now, there are general guidelines where you should use pointers and not use pointers, and a common beginner mistake is to use pointers to instantiate structs. So let's create a quick struct here called cat, and every cat is going to have a name, which is a string, and then an age, which is we'll go with uint, and I am messing up my syntax here. It's type cat struct. So now that we have our cat here, beginners who are new to pointers may create a function that's going to fill in the values of a cat. So down here, let's create a func called new cat, and in here it would say it's going to take in a parameter called cat, and it's going to be a pointer to a cat value. And so then from here, it can just get assigned the name is equal to Mochi, which is my cat, and then age is equal to 5. But this is not how you should go about instantiating a struct. This is actually bad practice. It causes more garbage collection. I don't recommend it, but we'll go ahead and demonstrate that this still works. So here I will have a cat. So we'll say cat is equal to cat right here, and then we call new cat, pass in the pointer to that cat, and then if we were to then print out the cat's name, we should get Mochi. So save, run this, and we got Mochi was printed back. So this is all fine, but it's just creating extra work for your garbage collector during runtime. Instead, what you should do is you create your functions such that they will return a cat. So instead of this, we should say this new cat function is going to return a cat. So then all we need to do is just take this line, put it in here, say name is Mochi, and age will be equal to 5. And that's all we need to do. We just return the cat, reassign this up here, so var cat will be equal to that. And now we can go ahead and print the cat's name again. So we'll do a go run, and we get Mochi back now with a capital M. And that's the bare bone basics of pointers in Go. And actually in a lot of other programs, or in other programming languages languages too. At the end of the day, pointers allow you to access the very memory location of a particular value, and that's it. So if you learned something in this video, I encourage you to like and subscribe, and I'll see you in the next one.